Yo, okay. This video is response to the comment above. This is a company in America called Red River. You see, it says how to check expansion tank pressure, a complete guide. Now these guys do everything from domestic to commercial, but mainly commercial. And you see how big the expansion vessels they deal with, much bigger than our normal applications. So surely they would know what they're talking about. And if it says here, if you're maintaining a home heating or boiler system, understanding the role of the expansion tank, also known as an expansion vessel, is crucial. One of the key aspects of ensuring the smooth operation of your system is knowing how to check the expansion tank pressure. This guide will walk you through the process, explain why it's important, and provide tips for troubleshooting your expansion tank pressure effectively. So obviously you can go look at this in your own time, but I'm going to skip down to where it's important. So here we go. Signs of a faulty expansion tank or incorrect pressure. There are a few common signs that your expansion tank may need attention. Frequent pressure drops, pressure relief, activation, water from the air valve, unusual noises, visual leaks or system shutdown. So you see, they deal with the same issues we deal with, dealing with boilers and other heating systems, okay? Now, why maintaining the right pressure matters? There you got pressure spikes, leaks and pipe bursts, system inefficiency, and premature failure of components. So if you see the key point there, it says system inefficiency. A waterlogged expansion tank or incorrect pressure causes your system to shut down or malfunction frequently. So the key point was that if water's coming out of the Schrader valve, certain people think that the valve is just gone altogether, but these guys are going to explain it. But if we keep going down, so these are all different things, but here we go. Now here we go, we're going to go through these points here. It says, how do I check the expansion tank pressure? Simply press the valve pin, or as we were describing, the Schrader valve, to release a small amount of water. If water comes out, your expansion tank is full of water. Then use a tire pressure gauge to check the air inside the tank. Number 2, what does it mean when the expansion tank is full of water? When the expansion tank is full of water, it means the air chamber has been compromised, usually due to a damaged diaphragm. This prevents the tank from absorbing pressure changes, leading to system problems. How often should I check my expansion tank? It's best to check your expansion tank pressure once a year, ideally during your annual boiler service. What happens if your expansion tank fails? If the tank fails, pressure in your heating system will spike, causing leaks, frequent pressure relief valve activation, or even system shutdown. And here's the key one, which I was trying to explain earlier. Can I fix an expansion tank full of water myself? In some cases, repressurizing the air side can fix the issue. But if the membrane is damaged, replacement is necessary. Professional help is recommended. So you see here, even in their own guidelines, they're saying, if you go back up and it says here, when they're talking about it being full of water, even with it being full of water, they're saying that it potentially can be repaired by repressurizing the air side, can fix the issue, but if the membrane is damaged, replacement is necessary. All right, so in certain cases, you can save it, and here is why. So again, if we go, I've saved it here, expansion vessel design. It consists of a fabricated pressure vessel, water system connection, air valve, and a membrane or diaphragm or bladder. The membrane or bladder separates the precharged air or nitrogen from the system water. Membranes are usually retained centrally in the vessel by crimping two halves together. Okay, so that's how they do it. They crimp it together. I think in other ones they weld it together. It depends on the manufacturer and the application. So if we go here, we will see that there's many different designs. So the key one a lot of guys will come across when they're dealing with an accumulator, which is basically just a really big expansion vessel. The bladder actually holds the water in this case. It doesn't hold air. And then the actual valve itself is pushed down. It's like a normal Schrader valve. I'll get a picture of that in a second. So you see here, the air is separate from the bladder. So in this particular design, the bladder holds water. Similar to this one again. You've got air at the top and then water coming in. Same with this one here. You got air all the way around it. The one in the middle here. And then on the right hand side, you got the bladder going all the way through with air around the side of it. So there's lots of different designs. Okay. And then here's another one. Diaphragm expansion tank design. So you see this one, the air is separate from where the water comes in, but you see the connection can either be at the top or the bottom. So it's depending on the manufacturer, really dependent on the manufacturer. All right. Now, why this is key, I'm going to get to it. Here's another example. You see the bladder. So we think we're charging it with air, but we're not. I'll type it in here. Schrader valve. And if I go to images, you see there's lots of different types. So you've got this one here where it slots into place. So that, I'll zoom right into it. So see the seal, that will go into the metal at the top, or wherever it's located in the vessel, and then that will hold the seal, and then you pressurize the whole chamber with air. But you also got other ones, slightly different design. I'll see if I can see it here. I'll have to type it in. Schrader valve with tube. And this is similar to a car tire. So you see here, this is where it holds it from the inside. That's what we normally see. We just see the top part, right? But then you also got ones which are designed like this. So it always depends on the manufacturer, what they decide to do. And that's why it says in some cases it can be saved by just recharging it with air, because sometimes we see water coming through, but this particular seal might be gone. And of course, because the two, like it says here, the membranes are usually retained centrally in a vessel by crimping two halves together, the actual air pressure, similar to like a car tire, will actually hold it in place. Because you see with certain car tires, with the air being pushed in, that actually holds the seal. And funny enough, a car tire works around about 3 bar worth of pressure, which is similar to a pressure relief valve. All right. So again, it's not 100%, but even the manufacturer, one of the main manufacturers that may be actually manufacturing a lot of the vessels you may come across, whether it's a domestic or commercial boiler, it says it here. If we go down to 0.5, can I fix an expansion tank full of water myself? In some cases, repressurizing the air side can fix the issue, but if the membrane is damaged, replacement is necessary. So just because we see water coming out of the pin doesn't necessarily mean that the membrane is damaged. And if I go back to this great example here, where it's crimped together, you see the 2 white dots where it would have crimped the vessel together, there may be a little bit of movement, which then would allow a bit of water to come through, because it's the air pressure holding the bladder in place. Same here. The air pressure is holding, even though the bladder is crimped together, it's still being held together. So if there is a issue, like if the air gets too low, the bladder can expand too much and break the seal. So similar to this design again. Okay. And let's see if I can find one more. Here we go. This is even better design here. So you see here, the rubber seal, it pushes against the case of the vessel. You see with the compressed air cushion, right? You see that? But if the air cushion is a bit low, the expanded water section of the bladder will expand too much and it will break the seal on the side here. right? You see, it's just held in place by the pressure alone. So sometimes recharging it can reseat that and get you up and run again. So I hope that's clear. And again, the more I keep looking at it, the more it makes sense again and again and again. All right. Again, the vessel's just squeezed together. That's how it looks on the inside a lot of the time. Here's another example. So yeah, I think this one's even better. At the bottom there, you see, so lots of different designs, but all pretty much the same concept. See that one, it's got a tube coming down into the bladder, you see? So the seal can be lost when it's being pushed apart. So this is what the manufacturer's saying. I'm just the messenger. If you just want to change it first all the time, that's on you. But the manufacturer says sometimes these can be repaired with air. And there we go, you see? This is a great example. Air is in there, the bladder is held in place, and then as it expands, it can slightly break the seal slightly. So just by reseating it, that can repair it sometimes. And again, if we're trying to save the customer money, sometimes when they don't have it straight away, if you can at least save the vessel, you just buy them a bit more time.